Hi guys, welcome back to another video. Today we're going to be looking at the following geometry problem from Mathcounts 2021. And let's have a quick read. So we have a square ABCD shown, which has side length of 6. And points P and Q are located on sides AD and BC, such that AP is equal to BQ is equal to 1. Triangles ACP and BDQ overlap in the square to form the shaded quadrilateral, as we can see in the diagram. And we're asked to find the area of this triangle. Okay, so let's start with just writing down the information we know, right? So we can zoom in a little. So we know that they give us the side length of the square is 6. So 6 for the side lengths. And we know that AP equals BQ equals 1. So we can write 1, 1, which would make this 5 and this 5. Okay, so we want to find the area of the shaded region. And now this shaded region isn't a square or a triangle or any other shape that we really know how to find the area of from any formulas. So we have to kind of be creative in approaching this. Okay, so the way that I would personally approach this problem is I would basically put this entire picture on the coordinate plane, right? Because then, for those of you that may not know, you can find the area of any polygon quite easily if you have the coordinates of all of its vertices. And we'll look more into that as we get there. But basically, it's a formula called the Shoelace formula. And that will give you the area of pretty much the quadrilateral. So let's zoom in and let's throw this entire diagram on a coordinate plane. Right, let's get these out for now. So we want to think of a strategic place to place the origin because everything is based off of the origin, right? So we have two options. I like to put it at A because if we put the origin down here, this is our bottom left corner, everything else in the diagram is up and to the right. So that means that all of our coordinates will be positive. So let's do this basically. So B has coordinates of 6, 0, right? Because we know that this side length has length 6. And similarly, P is going up 1. So that is 0, 1. D is 0, 6. C is 6, 6. And Q is 6, 1. So these are the straightforward points, if you call them. Now, if we look at this point right here, right there, this isn't too hard because this is just the center of the square, right? It's just the intersection of our two diagonals. So this would be half of AB and then half of AD. So that's just 3, 3. Okay, so that coordinate is not bad. Now let's approach, let's mark it in red, maybe, this coordinate. How can we find that red coordinate? So here we basically we see that red point is the intersection of 2 points. It's the intersection of 2 lines. So that would basically mean we want to find the equation of the 2 lines and then find the point of intersection. So let's start with PC. PC. So this has one of the points is 0, 1. And another point on that line is 6, 6. All right. So now if you think about the equation of a line, what do we need to find the equation? Generally, you need the slope and another point, right? So here, let's start with finding the slope. The slope, if we say m, that's usually the notation we use for slope. So m is defined as a change in y over the change in x. So that would be 6 minus 1 divided by 6 minus 0. And that is just equal to 5 over 6. So that means PC has a slope of 5/6. And then now the other thing, this will mess up the alignment. So now the other thing that we want to look at is instead of, now we have the slope and we know a point. We know 2 points actually, right? So we want to pick one of the points. And what we can do is actually take our intercept value, right? Because the intercept is that makes it easier. You could just use the y equals mx plus b. So y equals mx plus b, if you remember, this is called point slope form. Or sorry, not point slope, slope intercept, right? Y is just, that'll say our variable. M is 5 over 6. And now what's b? B is our y intercept. And we already know that in the graph, or in the diagram, the y-intercept of PC is just p, right? Which is 0, comma 1. So you have y equals 5/6 x plus 1. So that's PC. Now the other line that we want to find the equation of is BD. Now BD isn't bad. BD is just, it's a line from 0, comma 6 to 6, comma 0. So rather than going through all this process, you might realize just real quick that our slope is -1, right? It's just for every unit I go to the right, I go down 1 as well. So let's say we work on the side here, BD. So BD has a slope of 1 and a y-intercept of 6, or a slope of -1 and a y-intercept of 6. So this would be our equation for BD. So now to find the point of intersection between the two lines, all we have to do is set the two equations equal to each other, right? So we basically just want to do y equals -x plus 6, and we have y is also going to be equal to 5/6 x plus 1. Solving this second half, we get 5 is equal to 11 over 6x, which means x is 30 over 11. Okay, so this gives us x. And now to find y, all we have to do is plug in this value of x into one of our equations. So let's plug it into this equation right here. This equation is a bit simpler. So we just want to do -x plus 6 to get our y coordinate. So this means that our point of intersection, so let's say point of intersection, is 30 over 11 for our x coordinate. And then our y coordinate would just be, so it's basically 6 minus 30 over 11, which is 66 minus 30, so 36 over 11. Okay, so now let's take this information and update our graph, or our diagram. So just 30 over 11 and 36 over 11. 30. Yeah, so this is 30 over 11, comma 36 over 11. Now we have to find one of our other points. If we start here, we could go through the same process, but that's kind of time consuming, right? So the quicker way to do this is notice that this point is symmetric to the point we just found across the line x equals 3, right? Our y coordinate's clearly the same, so we could already write in 36 over 11 as our y coordinate. And we just have to find the x now. And you'll see the x is symmetric across x equals 3, right? So what is x equal 3? X equals 3 is just 33 over 11. So if I go 3/11ths from the left point to the middle, then I'll add another 3/11ths to get to our new point. So we just get 36 over 11ths again, right? And you could also see this because the line AC, that's just defined by the equation y equals x. So if we already know our y coordinate's 36 over 11, then our x coordinate must also be 36 over 11, right? Okay, so now all we really have to find now is this top point right here. So this will take a little bit of work, but it's not too bad because we already have the equation for PC, right? PC is already found, and we could confirm. PC we found to be 5/6 x plus 1, right? So now if we want to find dq, before we start cranking away to find the slope, we know the slope of PC is 5 over 6. And dq is just, basically, it looks pretty similar to PC, right? And the idea is it's just 5/6, but it has a negative slope. So slope of dq is just -5 over 6, right? So we already have that information. We don't have to waste too much time figuring that out. Here, let's mark up here. So we know our slope is, our equation will look something like -5 over 6x. Let's separate this. This is for dq, line segment dq. So our slope is negative 5/6 x. And now what's our y-intercept? That is just point D up here, right? So that's plus 6, right? So this is the equation of line DQ. So now if we set line DQ equal to line PC, we should get our topmost red point, right? And we already know the equation of PC to be 5/6 x plus 1. So now all we want to do is set negative 5/6 x plus 6 equal to 5/6 x plus 1. So that means 5 is equal to 10/6 x. And 10/6 we can just write as 5/3 x, which means x is equal to 3, right? And x equals 3, if you think about it, we solved it out, but that wasn't too hard to figure out because, again, that's just symmetric. That's in the center of the square, at least in the x direction, right? We have to figure out the vertical, the y component, but the x, you could have just looked at the diagram and seen that it's 3. But anyway, so we solved that. So we know that our x-coordinate of this is 3. And now for the y-coordinate, we just pick one of the two equations we created and plug that in. So if we just look at, say, y equals 5/6 x plus 1, right? Let's circle it. This equation here. Plugging in 3, we get 15/6, and that's just the same as 5/2, right? 5/2 plus 1, that's just 7/2. Okay, so this is kind of messy. Let's bring this down here. Basically, what we have now is we have a quadrilateral that looks something like this, right? So we have something that looks like that, and that's right in our coordinates. We have 30/11, comma 36/11, 36/11, comma 36/11, 3, comma 3, and then 3, comma 7 halves. And now we have the coordinates of our quadrilateral, so we just want to find the area of this, right? And so this is what I was talking about before. This is something called Shoelace, where it's basically, it might look kind of scary and daunting, but it's not too bad. So it's more like an algorithm, and what you want to do is start with any corner. Let's start with 3, comma 3. And now what we have to do here, write down all of our coordinates starting from some point, and we work in a certain direction, right? So let's just pick, like, say, clockwise. So after 3, comma 3, we go to 30/11, 36/11. Then we have 3 and 7 halves. And then we have 36/11, 36/11. And then we have 3, comma 3 again. So you write the first coordinate again at the end. And so from here, this is where the name Shoelace comes from, by the way. You want to basically cross multiply like this. So every line that I've drawn, you multiply the two numbers. So like if we start with this 3 and this 36/11, we get 108/11. And let's just write it next to these. And then 30/11 times 3, so this 3 times this 30/11 gives us 90/11. Okay, so that's done. Now we work with this and this, right? 30/11 times 7/2. So that is basically 210/22, right? Sorry, which is the same as 105/11. And then you have 3 times 36/11, that's 108/11. Okay, so that's done. Now we want to pick this 3 and this 36/11. That's 108/11. And then we have 7/2 times 36/11. So let's see, this is a little bit more work. So you have the 36 and the 2, 18 times 7, you get 126/11. Yeah. And then we finally end off with 36/11 times 3 is 108/11. And then you have 108/11 again. So this is complete now. And we basically add these values right here on the left side. And then we add the values on the right side. And then from here, so we could add it up, but you'll see it might not make the most sense just yet. because, so if we just write this out in a little bit of a neater form, 108 over 11 plus 126 over 11 plus 108 over 11. Then basically what you want to do is you take the absolute value of the difference of the sums of the left and the right sides. So here on the right side, we had 108 over 11 plus 105 over 11 plus 108 over 11 plus 108 over 11. So you want to take the absolute value of this and then just multiply it all by 1/2. So I know it looks kind of like black magic type of thing where you might not understand, but this is pretty much how it works. And the proof of this is kind of long and complicated. So basically we'll see 108 and 108 over 11 cancel. Then this 108 over 11 and this 108 over 11 cancels. So what are you left with? On the first term, from the first term, all we have is 216 over 11. And then subtracted by 105 plus 108, which is 213 over 11. So then this is equal to 3 over 11, and then multiply this by half, you get 3 over 22. And this would be our final answer. And so the area of this shaded quadrilateral would be 3 over 11, and that would be it. So we'd write that down, or sorry, not 3 over 11, 3 over 22 we got. So we get 3 over 22, and we'd be done. So if you have anything else, any other questions, feel free to leave a comment. Otherwise, like and subscribe, it'll help us out. And I'll be back again tomorrow with another video. Thanks everyone for joining.